question here, quiz question. So we can see it. Very, yes, we made it. Okay, we want to find the intercepts of this equation and graph. So x-intercept y equals 0. So 2x minus 6 times 0 equals 18. There goes boy. See where I needed to be. There. Okay. And I'm gonna move this over just a little more. Don't pay any attention to that stuff over there. It's a different class. Okay, so we do this and we get 2x equals 18. We divide both sides by 2. Don't skip that step, but there it is. X equals 9. Now this gives the point 9, 0, because we let y equals 0 and found that x has to be 9. So that's going to be a point on our gradient. So if we do the graph down here, we'll say that this is the line x equals 9. This is a 0.90. Okay. Then y-intercept is at x equals 0, which gives you 2 times 0 minus 6y equals 18. So that y equals -3. So your y-intercept occurs at 0, -3. So I'll just say here's the line where y equals -3. And here's your y-intercept. And then now I say you can look at this point. You do draw a straight line through it, but I'm at a bad angle here. So, you know, I might end up here. But let's see if I can get it right. Oh, it's pretty good. But yeah. My hand had a little glitch there, so it went a little too high, but it's okay. All right, so this is a line. Two x minus 6y equals 18. Okay. Now, I next ask you to find a line with the same slope, y-intercept 0, -5, right? Well, first, I said find the slope. Okay, to find the slope. Now, what everybody did was pretty good. I saw an arrow going this way. I'd like to see an arrow going this way on the graph. Then I'd like to see this all made into triangle. Okay. And we could say the run equals 9 minus 0, which is 9. And the rise, can't read that, is 0 minus -3, which is 3. And I prefer that all gets written in just to reinforce this so you don't forget it. Okay, it's really easy to forget this if you don't have a good picture. So now the slope. This out slope is rise divided by run. Equals 3 divided by 9 equals 1/3. Put that 1/3 in a box next to the line. Okay. Now, if you're not in my section, that's not going to be required, but I still kind of recommend it. Again, it's a good way to remember what you're doing rather than following a formula that's easy to mix up. I had a good student in class yesterday who had 2 points. But for the rise, he subtracted the x coordinate of one from the y coordinate of the other. And then the y coordinate of the second minus the x coordinate of the first. Have something made absolutely no sense. It didn't even have the right, the slope was down instead of up. Okay? That's what happens when you use a formula and do it carelessly. If you have this picture, you're going to immediately see that you screwed it up. And if you can relate the picture to the formula and the formula to the picture, then you understand it in a way that you're not likely to screw it up when it counts. Okay? Because there are all kinds of ways to screw up. I find new ones every day. And you have to know how to guard again. So good way to guard against that sort of a screw up. Okay. So anyhow, got that. So now same slope. Y-intercept from 0, -5. Well, y equals mx plus b, where m is your slope, and b is the y-intercept. So we see that if the y-intercept is at the point 0, -5, the y-intercept is -5. M is 1/3. Okay. And now b is -5. So y is 1/3 x plus a -5, and of course that'll just come out as a -5. Now I've asked you to graph this. So I'm going to repeat the first graph. Y equals 1/3 x minus 3. My second graph will be y equals 1/3 x minus 5. So of course, here's the point 0, -3. Here's my new y-intercept, or my y-intercept for the second line, 0, -5. And it's got to be parallel to this line. So we could say, well, this is 2 units lower than this. Go down 2 units. Actually, maybe put that a little higher. Okay. And then go down the same distance from this point, since the line is going to be parallel. This point has to be the same distance below this one as this one is below this. And then we just sketch our line. And now we have y equals 1/3 x minus 5. Now everybody did real well up to this point. Then I asked something that we hadn't really gone over, and I don't think we went over it in pre-calc. Even though the assignment was due, I was hoping everybody would get it by doing the assignment. And not everybody in here did this time. Fine, but they're doing very well, so I'm not too worried about them, okay? But you know, do get caught up if you happen to be behind. And then people had trouble with this kind of a question. Okay, so let's see how we do this. Okay, so the line is through. Seven -1, right? Yeah. Negative. Well, we could draw a picture of this thing. 7 -1 is pretty close to this line, right? It's so close that I don't want to draw that. Okay. I'm going to make it 7, 1. So I'm changing things on you a little bit. Now, what some people did was they sketched the graph. Okay. And they got a graph, and the sketch I saw was on a graph that had this line, but not this line. I didn't say do them both on the same axis, but I'm doing them on the same axis to show you something. That's another thing that people are having a lot of trouble with. Okay. So I'm going to make the thing 7, 1. And if this is 9, then 7 is going to be about here, and 1 is going to be about here. So the line is going to look a lot like this. We count 9 units back and 3 units down to find that we're about here. So this line is going to be parallel to both of these, but it goes through the point 7, 1. So we could write that so now we have 3 graphs. Okay, how do we get the equation this way? Okay, well, we put in the information we do have, which is that the slope is 1/3, but we don't know what the y-intercept is. Okay, we could kind of figure it out by counting over, but if these are decimal numbers with a few significant figures, you're not going to be able to count over them and make accurate estimates. Now you could make an estimate. Okay. Now you made an estimate. It looks like the y-intercept here is about negative 1.6. Approximately it's 0, negative 1.6. Question mark around that because we're not sure. But there it is, and it's probably not too far off. Okay, so it is P equals negative 1.6. So our estimated function would be y equals 1/3 x minus 1.6. To check, we let x equal 1, y equal x equals 7, y equal 1. We get 7 equals 1/3 of 1. Sorry, y equals 1. So the x is 7, y equals 1, x is 7. Numbers I had that were not going to work out, and it's minus 1.6, 1.16. Okay. So we get 1 equals 1/3 is 0.33. 1/3 of 7 is 2.66. Okay. So y'all start doing your arithmetic right, like I do. That's 7/3, which is not 2.66, it's 2.33. So 2.33 minus 1.6 is about 0.73. Okay? Close. Wasn't a bad estimate. But now we want to know really well, what is it? It's close. The y-intercept is close to negative 1.6. Okay? So we could actually figure out what the y-intercept ought to be. Okay, it ought to be like 1.33. Because if it was 1.33, then the subtraction would give us 1. Okay? If this is 1.33 instead of 1.6. So we already kind of know what the y-intercept ought to be, but we're going to write this as an equation. So to find the exact y-intercept, we know that y is 1/3 x plus b, and y equals 1 when x equals 7. So we're going to do the same thing we did here, but we're not going to use an estimate for b. We're just going to let b stand for b. We let b be b. Okay. So we're going to get 1 equals 1/3 x plus b. Solve for b. Okay. Well, to solve for b, remember we've got a denominator. We want to clear the denominator. So multiply this side by 3. And we multiply this side by 3. That gives us 3 here. And I'll write it out. 3/1 times 1/3 times x plus 3 times b. So that 3 equals x plus equals, it's not 1/3 x, it's 1/3 times 7, because I didn't replace x. Okay. So it's 7/3. Now you can see what I did in this step. I replaced y by 1, but then I didn't replace x by 7. Because I was thinking ahead and not thinking ahead very clearly. Okay. So replacing x by 7, this is what we get. And it's not 7/3 anymore because the 3's divide out. It's going to be 7 plus 3b. So then people like to do it this way. So we'll subtract -7 equals -7. And we get -4 equals 3b. So that b equals -4/3, which is the -1.33 that I said would work for this approximation. Of course, 4/3 is -1.3 repeating. 3's go on forever. And the 3's here would go on forever. I rounded off the 7/3 here because we're doing an estimate. We didn't need any more than just a couple of decimal places. Okay. Better to use the fractions. B is -4/3, and this is exact. So the equation is y equals 1/3 x minus 4/3. Okay. Well, now let's go back to this graph because I want to do something in addition with this graph. I'm going to copy it. And I'm going to draw my 3 y-intercepts. This is not an exact graph. We're not going to be able to make very accurate estimates from this graph, but it represents our three functions. And this is y equals 1/3 x minus 4/3. This one is y equals 1/3 x minus 3. And this is y equals 1/3 x minus 5. Okay. And this point is going to be where x equals 9. Okay. I've got this one a little bit too high, and it's not very good, but we'll go with this. Okay. So now I want to define f of x equals 1/3 x minus 5. I'm going to position that differently. One-third x minus 5 when x equals -1. And I want it to equal this function when x is between 1 and 4. And then this. And I'll take a x equals 9 label and put it up here so that interfere with what I've written here. Okay. Now I've got everything here I need to make my graph. If x is less than -1, well, I'll go ahead and draw a line here for x equals -1. Here's x equals -1. Okay. X is less than -1 to the left of this, right? Yeah. So x is less than -1 is from this line all the way to the left. Well, if x is less than -1, this says I follow the graph of 1/3 x minus 5. That's what it's saying here. Whenever x is less than -1, I follow the graph of this. Okay, so 1/3 x minus 5, that's this graph. So I'm going to include the point where x equals -1. I put an open circle around it. Okay. So I've done just what it says. When x is less than -1, I follow the graph of y equals 1/3 x minus 5. Okay. Then between 1 and 4, I'm going to follow the graph of 1/3 x minus 4/3. That means starting at 1, going up wherever x equals 4, would probably be about right now. These are closed dots because it's less than or equal. X can equal 1. So when x equals 1, we do include the point. We don't include this point because x is not less than -1 at this point, right? And then on the rest of the interval from 4, for any number x is greater than 4, here, in here we can write out one less or equal to x less or equal to 4. Here, just so we see what these intervals are. But we're going to include this function. But with an open dot because 4 is not included in this part of the domain. So the blue graph represents this function. Okay, function goes along merrily along this line from negative infinity all the way up to here. But just before it gets here, or just the instant it gets here, it says, nope, I'm going to jump up here. Okay, now I'm going to follow this line up to this point and including this point. But now I'm going to jump down here. Yeah, I shaded the wrong function, and I did such a nice job of it too. Should have been this one. Sorry, careless. What time so far already? Okay. So that'll dry and then you need to sketch the rest of this one. Make sense? So there is, blue graph represents this function. So I put a big blue circle down it, indicate that it's blue graph. Okay. Now that should help clarify something. We'll also be talking about it in my section of the calculus, because people are messing this up terribly. Okay, for a couple of reasons. And we'll see. If I gave you this graph without telling you what the functions are, you would see that, well, for x less than 1, we're on this line. Okay, what's the equation of this line? Well, let's find 2 points in this line, because as soon as we find 2 points in the line, we can find the equation. Okay. So if you've got a grid here, you can get 2 points, or at least you can do a good estimate of 2 points. Now, on the open math assignment, there'll be 2 points on any one of these lines that cross 2 of the grid lines. So you know exactly what the points are. Okay. So again, to get this function from the graph, if you weren't given the functions, you have to get 2 points in this and figure out what this function is. Get 2 points here and figure out what this function is. Get 2 points here and figure out what this function is. Okay. Yep, that's not difficult. What you do, once you have 2 points, you can find the slope. Now that you know the slope, you can write this, right, with whatever the slope is. And you can use one of the points to find an x and a y and solve for b. So you just use this method once you figured out the slope, which is easy if you've got 2 points. That makes sense? I think it does. Now, you might forget that before you see it again, but your brain will have processed it to an extent. So we see it again in an hour. And when I write it all out, that should lock it in. Okay. So I do think you're in pretty good shape with this. Okay, now there is one more thing that we can do here. The y parts of these graphs are not part of the graph of f of x. So we can just wipe them off. So we're going to do that. Okay, so we're going to get rid of this, which I just changed from blue to white. And we're going to get rid of this. See where they were. But right there's a graph of our function with no confusing details. Now, I might be a little confused when where it's part of the y-axis, but you put that. Yeah, I guess I need some of the x-axis. Okay, so there's a picture. And the other thing I'll mention is we could have a graph that looks like this. Okay. What kind of function is that? Don't say it, but it's a squaring function. And since you've constructed it, you know what the squaring shape looks like. Now, this might be a little ambiguous. That could be an inverse square or a reciprocal, or even an upside down exponential. Okay, I think it's probably close to the reciprocal square, but you know, I need 3 points to figure out better what the graph is. Okay, and then this is just a straight line, so you just need 2 points in this line. Okay, and then from the graph, you would be able to maybe figure out what these other 2 functions are. So that's just another example of a piecewise function. So equals maybe a f1 of x, a f1 of x minus h plus k, a f2 of x minus, you make that h1 plus k1 and a1, a2 f of x minus h2 plus k2, a3 f3 of x minus h3 plus k3, and here whatever x is, here on between here and here, between here and here. Okay, and let's just go ahead and terminate this graph. So you only have 3 intervals. Now, you'd have to figure out what these functions are, but I write them in this form to show you that these would be shifted, stretched toolkit functions. Okay. And I think you've probably seen graphs like that in chapter 1. People didn't really know what to do with them. So, and we've been talking about other things with all the snow days and stuff. This is the first I've really talked extensively. Okay. Okay, just posing a question that kind of pulls a lot of stuff together. What if you wanted to find a straight line through 4, -3, and 12, 7? What's the first thing you do? What's the next thing you do? What's the next thing you do? Up to the point where you maybe don't know what to do, but maybe you do. Okay. And that would be like, you know, if these 2 points are on the graph of this linear function, that's how you would find function to put in for this last interval, right? But we won't worry too much about the piecewise function at this point. Let's just find a straight line through the 2 points. What's the first thing you can figure out that's relevant to the equation of that line? Well, I figure more incoherent than I am. So even a little something. Doesn't take much. Okay, so find a straight line through these points. Okay, well, we start by making a sketch. Put x equals 4 here. Put x equals 12 out here something. Put y equals 7 here. And put y equals -3 here. That looks about right. So we have these 2 points. We have 4. And we have 12. You can draw a right line. And then, you know, these are things that happen naturally, okay? If you got 2 points and you know there's a straight line involved, you just do this, okay? So we have this and we have this. We have this. This is a run. which is 12 minus 4, which is 8. This is the rise, which equals, I have room to write it all out, but it's 7 minus -3, which is 10. So the slope is rise divided by run equals 10 over 8, which we reduce the 5/4, and we put it here. As we did before, so I did that quickly, but when you're given 2 points, it's just kind of automatic. Especially if you know there's a straight line, even if you don't know there's a straight line, draw the 2 points on a graph. Okay? Okay, so straight line is y equals mx plus b. Now, everybody here use the point 4 -3. I'm going to use the point 12.7, just so I can show off and do arithmetic with bigger numbers. Okay? I get 12 equals, slope is 5/4. I always do that. First number I write is the first number I see. Then I've got to figure out what to do wrong. Okay. So we've got 5/4 and 12, plus b is 7. We multiply both sides by 4. Now we just write 4 parentheses and put this in there. We write 4 parentheses and we put all this in there. 5/4, 12 plus b. So we get 28 equals 4 times 5/4 of 12. Because we do 4 times the first term, plus 4 times the second term, which would be plus 4b. I don't have room for time.
Yeah.
We go through this and solve for b. Okay? And we'll see a little more. You gotta make that 4 like a 4/1 and multiply 5/4. And do all that. There are other things you can do. You can divide that 4 into 12. But once you have b, then you just put it in your equation and you have formula for your function.